So today we're going to be talking about refactoring for progressive web apps. Just a little bit about me. I am an engineering manager at SalesLoft. I work with the analytics team and also the API and integrations team. I also, as Mina mentioned, started the Women Who Code Network in Atlanta and have run several events because of that and under Women Who Code. One of them was called We Rise, was a conference that we did for a few years that focused on women in tech. But instead of just kind of focusing on diversity issues around women in tech, we really tried to showcase women in doing really badass things in tech. And so what we're doing this year is Refactor Tech, which is kind of taking that and expanding it. And so for any marginalized people who may not get the opportunity a lot of times to kind of showcase the amazing things they're doing, this is what we're doing for this year. So just a little shameless plug there. And so again, talking about refactoring your existing applications for progressive web apps. Or what really happened is how moving towards progressive web apps helped us focus on UI performance. So first, what are progressive web apps? A progressive web app uses modern web capabilities to deliver an app-like user experience. Progressive web apps are user experiences that have the reach of the web and are reliable, so they load instantly and never show the dinosaur, even in uncertain networking conditions. They're fast, they respond quickly to user interactions with silky smooth animations and no ridiculous scrolling. They're engaging, they feel like a natural app on the device with an immersive user experience. And so what are some of the characteristics, what are some of the traits of progressive web apps? So by definition, a progressive web app must work on any device and enhance progressively, taking advantage of any features available on the user's device and browser. They should be discoverable. Because a progressive web app is a website, it should be discoverable in search engines. This is a major advantage that most native applications over native applications, which still lag behind in websites in searchability. It should be linkable. As another characteristic inherited from websites, a well-designed website or progressive web app should use the URI to indicate the current state of the application. This will enable the web app to retain or reload its state when the user bookmarks or shares the app's URL. It should be responsive. A progressive web app's UI must fit the device's form factor and screen size. A progressive web app should look like a native app and be built on the application shell model, which minimizes page refreshes. And we'll talk a little bit more about the application shell model. It should be connectivity independent. It should work in areas of low connectivity or even offline, which is one of my favorite characteristics. It should be re-engageable. Mobile app users are more likely to reuse their apps, and progressive web apps are intended to achieve the same kind of goals through features such as push notifications. It should be installable. A progressive web app can be installed on a device's home screen, making it readily available. And it should be safe. Because a progressive web app has a more intimate user experience, and because all networking requests can be intercepted through service workers, it's imperative that the app be hosted over HTTPS to prevent any man-in-the-middle attacks. So thanks to the caching and storage APIs available to service workers, progressive web apps can pre-cache parts of a web app so that it loads instantly the next time a user opens or interacts with it. Using a service worker gives your web app the ability to intercept and handle network requests, including managing multiple caches, minimizing data traffic, and saving offline user-generated data until online again. Progressive web apps tend to be architected around an application shell. This contains the local resources that your web app needs to load the skeleton of your user interface so it works offline and populates content using JavaScript. If the application shell has been cached by the service worker, then on repeat visits, the app shell allows you to get meaningful pixels to the screen really fast without the network. And so just examining some of the business cases for using progressive web apps at SalesLoft, or kind of moving in this direction, one thing was performance and caching. We knew that that was something we were going to get and going to be working towards with progressive web apps. We just didn't understand how big it was going to be. Push notifications, we use push notifications currently in our app, a pathway to mobile, and also UX and performance kind of perception. So making sure that even in situations where you might have low connectivity or no connectivity, the app still looked like it was working and still looked like the user could start to interact with it. And so this whole kind of architecture comes together because of service workers and the app shell. And so we have this app shell with this dynamic content model that we're going to talk a little bit more in detail about. The app shell approach relies on the caching of the shell of your web application using a service worker. Using the app shell and dynamic content model greatly improves the app performance and really works well with service workers kind of caching as a progressive enhancement. Progressively enhancing your web app means that you can gradually add in features like offline caching, push notifications, and adding to the home screen or installing. So how does this all work together? So when the user accesses your website, the basic HTML, JavaScript, and CSS display. On the initial website visit, the page registers a service worker that controls future navigations on the site. Registrations create a new service worker instance and trigger the install event that the service worker responds to. When the service worker is installed, the app shell content is loaded to the cache, and once installed, the service worker controls future navigations on that site. Note that sometimes manually activating the service worker using the browser's dev tools or programmatically using the service worker APIs. After the shell content loads, the app requests content to populate the view. The app shell plus dynamic content equals the complete rendered page of your app. Next, if you're using kind of a single page application setup, the request for content will come through XML HTTP request or the fetch API, and the page content is fetched and used to populate each view. And so this is kind of just a diagram explaining a lot of what I was just talking about. You'll see this kind of the start of the installing, and then whether it's activated or not. If there's an error, then you'll get a notification to let you know that your service worker has not been activated or registered correctly. And then you kind of go into the cycle of being idle and kind of waiting for a request. And then once it is no longer needed, it will be terminated. And so just kind of reminding you as we kind of go throughout this journey, and keep in mind, this is a journey. There was a reason yesterday during the panel near the end when she was kind of touting us as success stories. I was like, whoa, this is a work in progress. So just keep that in mind as I show you some of our results and some of the things that we tried. So just to remind you, we wanted to make sure that we had a path to mobile, that we had a way to continue push notifications. We wanted to improve performance and caching, and we really wanted to improve the user experience and the perception of our performance. So we've been doing our research, and we felt we were already on the path to making our app more mobile friendly. We had just spent months making our app responsive. We have a few UI developers that if you mention responsive tables or like buttons to them, they still kind of like twitch a little bit. So there was a lot of work done, and so we were kind of proud of ourselves. We were kind of patting ourselves on the back, like, you know, we've already started. Moving towards a progressive web app should be easy. And so that was so tough that we were kind of like, okay, we're at least halfway there, have to be. But after seeing some of our results in Lighthouse, some at the time were in single digits. I can't remember which one was, but one was 6, like the number 6 by itself. But so after seeing some of our results, we went into this really dark place where we began to see Lighthouse not as this really useful tool that will lead us happily along the path to mobile, but more as the instrument of our despair. We just had no idea how much work we had to do. And so what was the problem? Well, there were several. And so time to first paint interactive was very high. JavaScript boot up time was extremely high. And again, we had this really inefficient caching policy, which we knew, but we didn't realize how much it would affect our migration along the path of progressive web apps. So you might say, you know, don't get down on yourself, SalesLoft. You know, you're still young. You've got a great personality. You've got your whole life ahead of you. So, you know, we kind of took that, we dusted ourselves off and decided to look at it in the same way that Lighthouse describes some of these things, as opportunities. And so just kind of thinking of all the things that it lists when you're doing a Lighthouse audit as opportunities, and kind of taking those one step at a time is some advice I would give. And so, for instance, consider lazy loading off screen and hidden images to improve page load screen speed and time to interactive. So these were some things that we actually took from this whole process and decided to implement, not really to get to progressive web apps. And this is kind of where the story takes a bit of a turn. There's a plot twist in that we determined that we didn't want to focus so much on progressive web apps. That was great. But what we really wanted to focus on was performance. We had been kind of lax in our UI performance up until this point, as you can tell by that 6 that we got from Lighthouse. And so we understood that this was a bigger issue. Like, it's a separate and bigger issue than moving towards progressive web apps. And so we started looking for different patterns, like how do we change this monolithic code base that we had to something that could start to perform better and could move us on the path towards progressive web apps. And so purple is a pattern for structuring and serving progressive web apps with an emphasis on performance of app delivery and launch. And so it stands for push, pushing critical resources for the initial URL route, rendering the initial route, and then pre-caching any remaining routes, and lazy loading and creating remaining routes on demand. Beyond targeting the fundamental goals and standards of PWAs, Purple strives to optimize for a minimum time to interactive, especially on the first use, and this is regardless of any entry point into the app, especially on real-world mobile devices. So think 3G, think something that's not incredibly fast. And also, you're wanting to maximize caching efficiency, especially over time as updates are released. And also the simplicity of development and deployment. So these are some main goals that Purple strives for. Purple is inspired by a suite of modern web platform features, but it's possible to apply the pattern without hitting every letter in the acronym or using every feature. Purple can work well if you have a single page app with the following structure. You have a main entry point of the application, which is served from every valid route. This file might be very small since it's served from very different URLs and therefore can be cached multiple times. Another characteristic is the shell or the app shell, which includes the top level application logic, router, and so on, and lazy loaded fragments of the app. A fragment can represent the code for a particular view or other code that can be loaded lazily. For example, parts of the main app not required for your first paint, like menus that aren't displayed until a user interacts with certain parts of your app. The shell is responsible for dynamically importing the fragments as needed. The service and service worker work together to pre-cache the resources for inactive routes. When the user switches routes, the app lazy loads any required resources that haven't been cached yet and creates the required views. Repeat visits to routes should be immediately interactive, and the service worker helps a lot here. So this diagram is just kind of showing some of the components of a single app that might be structured using, in this case, maybe web components, but you could also think of any kind of component-driven front-end architecture, whether you're using something like React or using some of the later versions of Angular or Vue. In this diagram, some of the solid lines represent static dependencies, so external resources defined in the files using like link or script tags. The build process builds a graph of all of these dependencies, and the server uses this information to serve the files efficiently. It also builds a set of vulcanized bundles for browsers that don't yet support HTTP 2. And so kind of getting into, digging a little bit more deeply into Purple, when you're pushing, preloading critical resources for the initial route, the key is to prioritize resources hidden deep in the dependency graph and make sure that the browser's network stack is busy as soon as possible. So let's say you have a single page app with code splitting by route, and you can push and preload chunks for the current route before the entry chunks. So that's something that you kind of get with kind of push and preloading your resources. When you're rendering, this one is essentially pretty straightforward, but you want to get things to interactive as soon as possible. We're in pre-caching any remaining routes using the service worker. This is really where service worker shines. Service worker is known as a client-side proxy, enabling developers to intercept requests and serve responses from the cache. But it can also perform initiative fetch to prefetch, then pre-cache future resources. And as far as lazy loading and lazy instantiating remaining parts of the app is relatively challenging to achieve, but it requires both code splitting and async importing. So keep that in mind when kind of moving towards lazy loading. And so one of the first bits of advice, I mentioned this a little bit earlier, when migrating to a progressive web app, is to start small. Don't try to tackle everything at one time because you'll get overwhelmed like we were initially. And so some other steps that you might want to take is really thinking, being very thoughtful about your caching strategy and trying to determine like what needs to be cached and how to cache it. Are the items that you're thinking about caching, do they almost never change? Is there any secure information that you wouldn't want to cache? So think about all of these things as you're kind of creating this caching strategy, and that will help you as you start to plan out what goes in your app shell and how you're going to separate some of this content. And so for us, we had this really monolithic Rails app. It was, at the time, it was Rails and Angular JS on the front end. Yes, I said JS, so not a fun time on the front end originally. So we were using kind of a critical gulp plugin that kind of became our app shell. Like the output of that kind of became our app shell. And then we used a similar step with templates and kind of breaking up our JS into specific components. So a lot of the theme of this refactor that we went on was breaking things up, was getting things into modules or components as small as possible. And so we were breaking up apart that and running our gulp task. And on build, we would separate the critical from the rest of the content, and then lazy loading any of our React components. And we actually started on another initiative because of this and created our kind of component library. And so this is what's being lazy loaded there. And so a part of this had to break away from Rails. I don't know if we have any Rails shops or Rails developers in the room. I know it's kind of a bad word at a performance conference. But so we're a Rails shop, and sometimes the way Rails kind of leads you to do things means that it leads you in this direction almost of kind of a monolithic application. And so we had to break away from the Rails way of doing things. And so instead of using asset pipeline, we had to move away from that. And we were relying on Ruby Slim templates, and we had to move away into delivering standalone pages via Rails. So we said goodbye to asset pipeline and hello to Webpack. And we started kind of breaking up a lot of our application into microservices, which was a huge step in and of itself. And again, a lot of times people think of, like, when you're refactoring for a progressive web app, oh, you're only going to be refactoring your front end. But there were definitely implications on the back end, and so that's what I really wanted to show here. We did a refactor of our public API. The next thing that we're working on that's coming up in the next few quarters is kind of moving towards GraphQL and client-side routing with React Router. And so as far as caching and planning for the offline state, you have to figure out what makes sense. What would a user expect to see in an offline situation? And what parts of your application are things that can be cached in that way? For instance, if you have a list of companies or a list of people that you're loading, the people in those companies are unlikely to change, at least the way our app is set up, are unlikely to change very frequently. So that might be something that you might want to cache versus another feature of the application like your analytics, which is going to be kind of real time. There's no way to kind of cache some of those resources. So you want to kind of think through that, kind of going back to your caching strategy and going back to, like, what do you want the user's experience to be when they're offline or experiencing low connectivity? And so just a few ways that we are measuring our progress. This is absolutely a work in progress, y'all. So y'all can keep the judgment, or you could talk about the judgment later afterwards. So Lighthouse was what we first used to kind of do some of this. And at this point, so you see why I said withhold your judgment. So when we were just kind of getting in this, we had done some things, but we hadn't kind of come as far as we have now. This was our numbers that we were kind of starting with our metrics. I mentioned that when we first started investigating this, like that performance number, I believe, was 6. So there was already some work being done. And so we've improved, this is maybe 6 to 9 months of work. And so this is, we've improved to about 68, I believe is what that says, and kind of moving forward with the best practices too. And some of that stuff is underway. We actually, because of a lot of this, we came up with a new team, and it's our front-end enablement team. And so they're going to be kind of our first line of defense on our front-end performance and any new kind of front-end challenges. So there are a lot of things that happened and kind of changed the culture of the company and kind of changed how we thought about performance on the front end, just because we saw these terrible numbers in Lighthouse this one time when we were trying to move towards progressive web apps. Someone asked, and I can't remember his name, but someone asked after the panel yesterday, I mentioned AppDex, and he asked how were we using New Relic on the front end, like to measure some of our front end changes. And so there is an AppDex number for the front end too, for your browser, and it kind of, you can set a number for it, or you can take New Relic's suggested number, and I think this is like 7 seconds. So when you see that 0.9 there, that's saying that 90% of our users are getting a load time of less than 7 seconds. And they break this down into not just, so those members are satisfied, and there are people who are either not satisfied or frustrated. And so they kind of separate that for your user experience. And then we've also been using Datadog. And so what we wanted to focus on were our top visited states. So we wanted to make as big an impact as possible. And so we started kind of going into Datadog and figuring out what are our slowest states and how can we optimize them. And we continue to measure all of these and kind of report on them weekly. And so I would just say, you saw some of our numbers. So if we can do this, if we can kind of move in this direction, you can do this too. You just have to take it one step at a time. And that is about it. You can find me on Twitter. I'm Erica Stanley, and if you want to learn more about Refactor Tech, just Refactor Tech on Twitter. Thank you.